So for this review problem, we have x and y are independent random variables distributed on the n positive integers, 1, 2, 3, up to n. We're looking for the probability that x is equal to y and also the probability that x is greater than or equal to y. Now before I start this problem, let me just visualize what's happening here first. So imagine we have the x-coordinate and the y-coordinate, and the x-coordinate can be anything from 1 to n. So I'll just draw it like this. And the y-coordinate can be anything from 1 to n. So we have a picture of possible x and y coordinates that look like this. And so the picture that x is equal to y would be just basically the line, all the points that are on the line x equals y. So the points x equals y would just be these points right here on the main diagonal. Whereas the second problem, x is greater than or equal to y, so that y is less than or equal to x, that would be these points here kind of forming this triangle like this. So I give this picture just so that you can visualize how the calculations is going to proceed. First off, we compute the probability that x is equal to y. Okay, so this is equal to, well, there's several things that can happen. This is the chance that x is equal to some number and y is equal to some number, and I add up over all of the possible numbers. So x can be 1 and y can be 1, x can be 2 and y can be 2, x can be 3 and y can be 3, all the way up to n and n. Okay, so this is equal to, the sum is I equals 1 to n of 1 over n times 1 over n, because the chance that x is equal to any one number is 1 over n, and the chance that y is equal to any one number is also 1 over n. And so I have a constant here, 1 over n squared, that's being added to itself n times. And so we end up with the chance being just simply 1 over n. And if that kind of makes sense, if we think about it this way, x can be any number, then y has to match it. The chance that y matches it is going to be 1 over n. Okay, now for the more complicated problem, x is greater than or equal to y. Okay, so for this problem we have that summation I equals 1 to n. Now the same logic, x can be any number, so x can be any number, but once x is picked, then y has to be less than that number. So the probability that x is equal to I times the probability that y is less than or equal to I. Okay, and so that's equal to summation I equals 1 to n of 1 over n times, now here we have I favorable outcomes over n possible outcomes. The chance that y is less than or equal to 5, that'd be 5 over n. The chance that y is less than or equal to 10 would be 10 over n, and the chance that's less than or equal to I is I over n. Now this one can't be done as simply as this one because this is no longer a constant. This is now going to be 1 over n squared plus 2 over n squared plus 3 over n squared and so on. So this is equal to 1 over n squared times summation I equals 1 to n of I. Now this is an arithmetic sequence, and the formula for an arithmetic sequence, if you have an arithmetic sequence, then the summation of the first n terms, the formula goes n over 2 times the first term plus the last term. The number of terms over 2 times the first term plus the last term. So applying that over here, I have the number of terms over 2 times the first term plus the last term. And so we simplify this, and we end up that this is equal to n plus 1 divided by 2n. And so that is the formula for the chance that x is greater than or equal to y.